a mass m, that is 50 grams, is dropped on a vertical spring with a spring constant of 500 Newton per meter at a height of 10 cm as shown in figure. The mass sticks to the spring and executes SHM. After that, a concave mirror of focal length 12 cm facing the mass is fixed with its principal axis coinciding with the line of motion of the mass, its pole being at a distance of 30 cm from the free end of the spring. Find the length in which the image of the mass oscillates. Alright, now first thing we have to note that, let's say mass which is at a height of 30 cm from the free end. Let's say this is my free end of the spring. So this distance is given to me as 30 cm to the free end. Fine. So first of all, I'll calculate the equilibrium point. The equilibrium point, that is at which the net force is 0. So when the mass is coming down, a downward force mg will be there. The spring force, that will be equal and opposite. So I'll calculate the value of x at which the net force will be 0, that is at my equilibrium point. So x will be given by mg by k. The mass is 0.050, g is 10 and the value of k is 500. So it comes out to be 0.1 centimeter. Alright, now another thing, this is the equilibrium point. This is the equilibrium point for the SHM. Now I have to calculate the extreme point. Alright, now for extreme point, the complete energy will be converted into spring energy. So I'll write mg, this height h, plus let's say delta is equals to half of k delta square. Fine, because if this is my original length, it is compressed by, let's say, delta, at which the complete potential energy is converted into spring energy. So just substitute the values. I have height as 30 cm, that is 0.30, plus delta is equals to half of k that is 500 into delta square. So the value of delta from solving this equation comes out to be 1.5 centimeter. Alright, now let's say that this is my point, equilibrium point, and this is my extreme point. So clearly this distance is 1.4 centimeter, that is the distance between the mean point and the extreme point. So the initial amplitude of the object comes out to be 1.4 centimeter. Alright, so object, that is a mass, will go like up to this point and vibrate like this. That is 1.4 below the mean point and 1.4 above the mean point. And the mean point is at a distance of 30.1 centimeter from the pole. Alright, let's say this is my pole. So this distance is given to me as 30.1, that is the mean distance. Alright, so I'll say that the object distance when it is at position 1 and when it is at position 2 can be written as 30.1 plus 1.4 with a negative sign according to sign convention, and u2 will be 30.1 minus 1.4. This is position, so this is my position 2, this is my position 1, because when it is at position 2 it will be 30.1 plus 1.4. so I get the two object distances as minus of 31.5 and this one will be minus of 28.7. Fine. Now what I have to do is just simply use the mirror equation. I know the focal length is given to me as minus of 12 centimeter. Fine. So just substitute these two values one by one. You will get the two image location V1 and V2. This V1 and V2 will come out to be minus of 28.7 centimeter and minus of 20.62 centimeter. Now this minus sign is just showing that it is on the same side, that is on the left hand side of the mirror. So the total length of the vibration will be given by, let's say total length will be given by 28.7 minus 20.62, that comes out to be 1.24 centimeter.